This is the beginning of a new CNC build. We're going to do one of the V1 Engineering LR3s or Lowrider 3s, and I think this is going to be a pretty fun project. I've wanted to do a big format CNC for a while, and figure wintertime is a good time to get going on this. So we're going to get started. Instead of printing all of the parts myself for this, and these files are available on the V1 Engineering site. If you've got a 3D printer or know somebody that does, you can just download those files and print everything yourself. For the MP CNC that I did about 6 years ago, I actually did do that. I printed them on my own on a very cheap 3D printer that was actually a kit when it arrived, and that worked fine. For this project, I went ahead and ordered the printed parts from V1 Engineering. And interestingly enough, as I was pulling out my parts for this Lowrider 3 build, I had my box of parts from the MP CNC, and this was sort of the heart of that MP CNC that held the router, or held the spindle, and I believe that was the spindle that we used. And this part was a real work of art. This thing was incredible. And again, this was printed on a dirt cheap 3D printer that was a kit in and of itself. So this stuff kind of folds into itself and is pretty cool to play with. For the computer control of this Lowrider 3, we're going to do this a little bit differently than is outlined on the V1 Engineering website. I'm a Mach 3 guy, and I prefer to play with my CNCs with old Windows-based laptops. It's just a simple way that works for my thinking, and these things are pretty cheap now. I think this laptop is 14, 15 years old, and it's totally disconnected from any internet activity. It is totally dedicated to CNC operation, and I've used this on several machines. A 6040, I think I used this on the MP CNC, and a few others. The way we're going to work the control board is also a little bit different, and there's a little bit of, not controversy, but people have different views on how to fly these things. Ideally, we should have 5 drivers for this build. I've been okay using controllers that just had 3 and doubling up the axes that we needed to double up. This control board came out of a broken 3040 CNC, one of those Chinese units, and we just have our X, Y, and Z axes here. So we're going to use this control board and double up a couple of the drivers that we need to. I also have a Toshiba driver controller, and they've been making those for a long time, and I've had good luck with that one as well, with those as well. So if this one, for one reason or another, doesn't work out too well, we'll switch over to the Toshiba one and kind of go from there. Several years back, I bought a few of these pendants to play with, and on something this large, I think these will come into play a whole lot. I have used these on some different builds, including the MP CNC, and it's kind of neat just to jog it around with these. And these are pretty much plug and play with Mach. You just plug that in. There might be some ports and pins or some setup stuff, but it's pretty straightforward. It works out really, really well. So this is the box of our V1 Engineering stuff, and I'm going to open this up and get going, see what's inside. These are the parts that I ordered. Kind of the stuff on the right hand side here are things that I had, and these old steppers and controller and stuff from my previous builds that I was tinkering around with before these items arrived. So it's sort of a split here. We're not going to be using these steppers because I did order new steppers in the kit from Ryan from V1 Engineering. So it's going to be a hybrid kind of DIY mix, and that's one of the cool things about these projects, is you can mix them up and sort of go in your own direction. So the next phase, and we'll be breaking this up into several videos, the next phase is going to be cutting some of that EMT 3/4 inch conduit into the appropriate sizes for this table. I went ahead and used the calculator on the V1 Engineering website so you can get the dimensions for the table that you're going to use. And that'll break down how long each run of conduit needs to be and gives you the particulars for that. Another departure that we're going to be making from more of the traditional builds is the use of limit switches. I've never put limit switches into the CNCs that I've built. I've built 4 or 5 of them or modified some other ones, and it's just not something that I've included in my CNCs. For 3D printers, I do include limit switches, or I haven't disengaged them from the machines that I've used or put together. But when it comes to CNC stuff, I've just either used the soft limits in mock or have been really cognizant of where I am on the board. Just individual choices, and everybody has to do what works for them. So we've got all of our parts here, our steppers, our linear rails for our Z. We've got our triangles here for our gantry, for our X going across, and our Y is going to be our long run. I did get the aluminum plates and still figuring out where all this stuff goes. I've watched a bunch of videos and looked at all the designs online, but I'm still putting together in my head the way this all goes together. And this is the central part that will hold the Makita router. Got that guy waiting right there. And these are the pieces that will hold our conduit along that side for our long Y, for our Y run. Extra wiring, and all of our individual parts. I believe this is for the dust shoe for the bottom of the router. These are for our belts. These look like the limits or some parts of our belt runs. So we'll get in there and see how that works. On the V1 Engineering website, they've got a calculator for the low rider, so you can design your bench, your table for the size that you want to use. And you can make this smaller, you can make this big. As far as our build here goes, this is a 4x8 sheet of plywood. It's actually 3 sheets, 4x8, and I had 3 sheets I was going to use for another project. These are actually 1/4 inch each. So we've got 3 1/4 inch sheets of 4x8 exterior grade plywood all put together, 3/4 of an inch. So it's a pretty solid, pretty strong table, and it's not going anywhere. And since I had this stuff on hand, it didn't make sense to go buy more material. So that's our bench. With a 4x8 bench, we obviously can't cut 4x8 material because the CNC will be using up a little bit of that. Even with that said, this is still a very large cutting area. If we wanted to extend out to the side, and then maybe something we'll do down the line, the cool thing about all this is it's adjustable. You can redesign at any time. But for now, building this onto this bench, we should have a cutting area of just about 3 feet by almost 7 feet. 3 feet by 7 feet. That is huge compared to what I've done before. If we want to do those extensions off to the side and the end, we could get quite large. But 3 by 7, that should cover me. Just to show these in action, here's a couple parts I made for a little boat I'm working on. So those are some transom knees, and I've just got these steppers that came with the V1 Engineering kit wired in, and they're just kind of running through their G-code. So we've got our Y-axis here, which will be our long run. We've got our X here, which is side to side, and then our Z is on the end as far as raising and lowering our spindle or our router. And we're just going through the cycle here. It's kind of, I know a lot of the software is similar in its visual aspects, but it also just kind of comes down to what you're comfortable with, and I've been playing around with Mach 3 for forever, so this is just a very familiar, comfortable screen for me. And it's always fun just to see these little guys going on their set path. And for this, again, as mentioned before, we've just got these doubled up. So for our X, we've got just one actually. Our Y is doubled up, and our Z is doubled up. So we're just using a 3-driver board. I've also been checking the temperature just to make sure that we're good on physical temperature for these motors, and these are nice and cool. So we're fine there. One difference with this board compared to some other boards is I can't change the current ratings on this one. I can't change those in Mach, so it kind of is what it is, but we seem to be okay in providing power to the motors. I could put a meter on this and see exactly what these draws are, but for the time being, just testing before we do any kind of larger assembly. Because I like to keep testing and trying the stuff that I've got on hand, I borrowed this from my 6040, this controller box here. And it's kind of nice because we've got the emergency stop and we've got the power there. We do have control here. If we wanted to put a spindle on the machine, we could borrow the spindle that's on the 6040 as well, but that spindle is a whole lot heavier than the Makita router, and the spindle needs water cooling, which adds to the complexity of everything. But just for using the controller in here, I got curious, so we wired this in, and just like with the other controller board, we're just kind of running through the motions here and letting this spin around. And again, it's fun just to watch these little guys turn, following an imaginary path. And the thing with Mach that I like, and a lot of the softwares do the same thing, is you can follow your design there and see all your code and stuff. But again, they all work about the same, or very similarly. But it's cool to see this controller here, kind of flying this as well. The other nice thing about this controller is I can control the current and the decay and the steps and the fine-tuning, whereas on that other controller board we were fixed. We didn't have breakdowns into micro steps, and on this one we do. But we're just kind of rolling through here. So I think we're going to stop this video here and kind of break this up into not a big series, but just a series of successes as we move along. Fun stuff. Thanks very much for taking a look.